This is the Introduction to Quads preview video. You want to make sure you write your name down as well as the location and the time, date and time that you are watching this video. You should also get a parental or a teacher or guardian sign-off. We're going to start first by doing a quick review here. It says you're going to graph a line 3x. Graph a line 3x minus 6y equals 12. Then graph a second line, which is perpendicular to the given line and goes through the point 4, comma, negative 7. Also write a slope-intercept equation of this line using the point-slope form to start. I want you to attempt to do this completely on your own. You have 3 minutes, and then I'll go over this problem. 3 minutes. Ready? Go. All right, let's see how you did here. So we start by graphing this original line, 3x minus 6y equals 12. So 3x minus 6y equals 12. I'm going to use intercepts here. To get my y-intercept, we pretend x is 0. So that's 0, comma. And we see y here is going to be negative 2. Now we're going to get the x-intercept. That's where y is 0. So it's blank comma 0, so we go like this. And 3x equals 12, and we see that y here is going to equal 4. Graph these two intercepts. 0, negative 2. and 4, 0. And you have your original line. Now we want to graph a second line, which is perpendicular and goes through this point. So we pull out the slope here. If we were to solve for the slope, this would equal y equals positive 1/2 x minus 2. If you were to change that to y equals mx plus b. So our given slope is 1/2. And you can check that. You go up 1 and over 2, and there it is. So our perpendicular slope, 1/2 times something, equals -1. Our perpendicular slope has to be -2/1. So for our second line, we plot the point 4, -7, which is right here, 4, -7. And our perpendicular slope is going to be a negative line, so I go down 2/1 this way, or up 2/1 this way. And we can see there is our line. Now we want the y equals mx plus b version of that line. So to do that, I'm going to use the point-slope equation of a line, which is y minus y1 equals slope x minus x1. So we plug it in, y minus, that's double -7, equals -2/1 x minus 4. Go ahead and we're going to distribute here. End up with y plus 7 equals -2x plus 8. Going to minus 8 both sides. Excuse me, we're in minus 7 both sides. And end up with y equals -2x plus 1. And that would be the equation of the line here. Let's go ahead and take a look at what we're doing today. We're going to be talking about introduction to quadrilaterals. Quadrilaterals, very simply, are shapes that have 4 sides. And our main vocabulary terms today are parallelogram, rectangle, rhombus, trapezoid, kite, and square. Here are the primary quads we are learning about today. And they are, by definition, any 4-sided shape, which just is a quadrilateral. Any 4-sided shape is a quadrilateral. So everything else on this page is a quadrilateral. Couple characteristics of a quadrilateral: it has 4 sides. Surprise, surprise. So 4 sides. But more importantly also, if you see here, technically a quadrilateral is 2 triangles, which both add up to 180 degrees. So all quadrilaterals, the angles will add up to 360. And that's true of all quads. The next and most important quadrilateral would be a parallelogram. Let's put the names on the inside here. Definition of a parallelogram is a quadrilateral with opposite parallel sides. So one set of sides parallel, second set of sides parallel. So it is a quad with 2 pairs opposite sides parallel. That's why it's called a parallelogram. Make this bigger so we can track with it. Now, a rectangle is a type of a parallelogram. Rectangle is a type of a parallelogram. And in fact, it is, by definition, it is a parallelogram with 4 right angles. So the definition of a rectangle is a parallelogram with 4 right angles. That's the definition of a parallelogram, of a rectangle. It is a parallelogram with 4 right angles. A rhombus is also a parallelogram, but it's a parallelogram not with 4 right angles, but with 4 congruent sides. So definition of a rhombus is a parallelogram with 4 congruent sides. So both a rectangle and a rhombus are parallelograms. And if you take both qualities of a rectangle and a rhombus, put a little arrow here in the middle, little arrow here in the middle, if a rectangle and a rhombus gets married and has a kid, they're going to have a square, because a square has both 4 right angles and 4 congruent sides. So that's an additional quad. Two other quads you should be familiar with would be a trapezoid definition of a trapezoid is a quad with only 1 pair of parallel sides. Unlike a parallelogram has 2 pairs, only 1 pair of parallel sides. Technically, we call these the bases, even though it's rotated on the side. The parallel sides would be 1 pair instead of 2. 2 would make it a parallelogram. A trapezoid only has 1. And last but not least, something that you may not have known is an actual geometric shape would be a kite. By definition, a kite is a quad with 2 pairs of consecutive congruent sides. 2 pairs of consecutive congruent sides. Consecutive means next to each other. So in this case, consecutive, instead of opposite, consecutive means the 2 sides that are next to each other are equal. These 2 sides which are next to each other are equal. Contrast that with the parallelogram, where opposite sides are equal. So make sure you can explain the difference between a parallelogram and a kite. So these are your main quads you need to be familiar with. So I'm going to be introducing something more that in class is the idea of a quad family tree. These quads are interrelated to each other to a degree. So the main ancestor is just your basic quad. It's any 4-sided shape. That's the main ancestor. And then the quad family tree we can break up into 2 main family branches. Just like in our human family tree, we have our mother's side of the family and our father's side of the family. We have 2 different branches of the family, if you will. Same thing in the family of parallelograms and non-parallelograms. In a quad, the family of parallelograms, these are all parallelograms, of course, would be the parallelogram itself, rectangles, rhombus, and square. Those are all part of the family of parallelograms. Those are all parallelograms. Non-parallelograms would be like the trapezoid, where you have only one set of parallel sides, and the kite. Those are non-parallelogram side of the family. For the rest of the lesson, we're going to stay focused specifically on the singular shape of a parallelogram. Properties of a parallelogram. There's 5 main properties of a parallelogram. You must memorize these, and the easiest way to memorize these, say this out loud please, is OCD. Say it just like that. The 3 O's with some little gusto there. Say it with me. Ready? The 5 properties of a parallelogram can be summarized by OCD. Let me explain. So it's 3 O's, a C, and a D. Properties of parallelograms. The first property of a parallelogram is the fact that opposite sides are parallel. Opposite sides are parallel. The second one you should be familiar with is not only are opposite sides parallel, but opposite sides are congruent. That's the second property of a parallelogram. Third property, opposite angles are congruent. So angles that are opposite of each other are going to be congruent. So it's opposite, 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 3 opposites. Opposite sides parallel, opposite sides congruent, opposite angles congruent. The third one is consecutive. Consecutive angles are supplementary. That means angles that are next to each other, not across from each other. Angles that are next to each other, like these two, these are not congruent, but they do add up to 180 degrees. Last one. Diagonals bisect each other, so you have one diagonal, does not bisect the corners, it bisects each other. Another diagonal, this implies that this point here is the midpoint going both ways. It is the midpoint going both ways. So these are the 5 qualities of a parallelogram. Opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, diagonals bisect each other. Your job, to the best of your ability, is right now, take 30 seconds and attempt to memorize these 5 qualities. 30 seconds. All right. Now I'd like you to take a moment and attempt to write these down. Another 30 seconds. Try to complete these sentences. Ready? Go. Okay, so you should read parallelograms have opposite sides congruent. Parallelograms have opposite angles congruent. Parallelograms have opposite sides parallel. Parallelograms have consecutive congruent angles, and parallelograms have diagonals that bisect each other. Now, knowing these 5 qualities, we're going to work through a couple problems here. Okay, so it says, if WAVE is a parallelogram, find the measure of all possible angles. What I'd like you to do is write out OCD in the margin to keep in mind what this means. So we have OCD. That first O says opposite sides are parallel. So let's do this. When you should look out for parallel sides, you want to watch out for armpits of the Z. So taking a look here, we can do this. Armpits of the Z. That means this angle right here must therefore be 41 degrees. We're told that the whole thing is 84. So from that information, let's get a little closer here, we can go 84 minus the 41, and we can get this angle right here, which is 43 degrees. And since opposite sides are parallel, we can also have armpits of the Z going this way. So if that's 43, this is 43. Let's see what else we can know. We also know that opposite angles are congruent. So right here, if this is 84, this whole thing is 84. And we see here that C, consecutive angles are supplementary, which means this angle here, 84, and this angle right here have to add up to 180 degrees. Consecutive angles add up to 180 degrees. So we can do this to find the other angle. We're going to go 180 minus 84. Of course, we get 96 degrees. So this angle right here, this pink angle, is going to be 96 degrees. And since opposite angles are equal, this whole thing is also 96 degrees. What else do we know? Don't overlook the obvious from the previous lesson that we have a triangle here, which means that this angle right here we can find because we have 43 and then we have this 95 here. So we're going to go 43 plus 95. We get 8. Together that's 138. We're going to take it away from 180. And we get 42. Which means armpit of the Z, this is 42. And then we have 96 minus 42. That means this right here is 54, which means up here is 54. But wait, there's more. You think you're done, but you're not, because, be really careful, there's more here. If this is 95, this is 95. And we see here, that's 180. So we can go 180 minus 95. And we get 85. So because of the qualities of parallelograms, because opposite sides are parallel, because opposite angles are congruent, and because consecutive angles are supplementary, you are able to find every single angle in the diagram. Let's try one more problem together. If the shape below is a parallelogram, find both variables and segment lengths. So let's keep in mind what our qualities are. O, so things that deal with segments, we have opposite sides which are congruent, and then this last one is diagonals which bisect each other. Those have to deal with segments. So if the diagonals bisect each other, that means we have a midpoint going both ways. So these are equal, and these are equal. So we can go 3f plus 5 equals 4f. And then we can go this way as well. 3g equals 9. Of course, we can solve for each. And we get 5 equals f, and g equals 3. So these two, diagonals bisecting and opposite sides congruent, have to deal with segment lengths. I'd like you to do is for the next 3 problems, 1, 2, and 3, you have 5 minutes. I'd like you to try to solve those on your own and then check. Okay, let's see how you did here. So here it's parallelogram, and we know that opposite sides are congruent, so we can easily make these guys equal. So we have here 4s plus 5 equals 6s plus 1. We can minus 4s each side. We have 5 equals 2s plus 1 minus 1. And we have 2s equals 4, divide by 2. And of course the variable s equals 2. That's 1. That's the first one. And then we know that this opposite sides are congruent again. This one you could actually just solve in your head. We know that 5r plus 1 equals 6. So you have to ask yourself, what would 1 be in this case? So what would r be in this case? And r would equal 1, the only number that works. Let's check out here. Solve for all variables. Well, we start with the fact that opposite angles are congruent, so I can go 5h equals 125. We divide by h, and therefore h itself equals 25. Once you know that, we can go this way, and 5 times 25 is 125. We also know that consecutive angles equal 180, so that adds up to 180. We're going to minus 125. We get 55. So this orange angle is 55. And if that's the case, this is 55. So for here, I can go 7k minus 1 equals 55. Plus 1, plus 1. 7k equals 56. K therefore equals 8. And here I have 11j equals 55. You divide by 11 and j equals 5. Here we're told it is a parallelogram, and we want to say, how do we know for sure that ADB, the triangle, is congruent to CBD? There's actually several ways you could have done it. Real simple, if we walk down our OCD, opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and diagonals bisect each other. Well, if we know opposite sides are parallel, that would give us armpits of the Z going both ways, so we would have a pair of angles, another pair of angles, or a side. So that would give us angle, side, angle. Or you could have gone this way, the fact that opposite sides are congruent as well. So there's a pair of sides, there's a pair of sides, and then all the way down the middle again. There's your third pair of sides. You could have easily done this side, side, side. Because opposite angles are congruent, that would give us an angle here. That would easily give us side, angle, side. In all honesty, all four could have been used. You just have to be able to justify your answer with an explanation.